Hey everyone, in this video I'm going to continue our discussion of randomized controlled trials, and I will talk about an example that was discussed in the book, which is a published experiment that examines the effect of social pressure on turnout. Specifically, in this experiment, was a field experiment, so this was conducted in the context of the 2006 primary statewide election in Michigan. And what the researchers did was they sent postcards with different randomly assigned messages to voters, registered voters. There were 4 different conditions. First, in the control group, registered or voters in the registry did not receive any message at all, so that's the comparison group. Then, secondly, we have a civic duty message. Thirdly, there was a message that basically just stated that people or voters were part of a study of voter turnout. So in order to kind of account for this potential Hawthorne effect, so the potential effect of people being aware that they might be studied. And then lastly, a neighborhood social pressure message. And the way this neighborhood social pressure message looked like is as follows. You can see kind of the template letter here. Dear registered voter, what if your neighbors knew whether you voted or not? It turns out, of course, whether or not someone voted is public record, or is part of the voter registration or part of the voter records. So this neighborhood social pressure message essentially contained information about actual neighbors and whether or not they voted in the previous election in order to increase the social pressure to vote in the next election, in the upcoming election, August 2006. The civic duty message, in comparison here, just emphasized how voting in of itself is a civic duty and that people should participate in elections. Okay, so this is a field experiment. This was not conducted in the lab. This was actually done with by contacting actual voters and then examining to what extent they participated in the election or not. And the randomized part is that these messages were basically with known probability, certain voters were assigned to being contacted with certain messages and others were not. And so therefore, if you kind of think back to the last video, by allocating this treatment randomly, we can basically say that on average, in expectation, the voters that ended up in the control group and the voters that ended up, in one of those treatment groups are comparable on all other characteristics, except for the fact that some received a treatment and some didn't. Okay, so I just want to go briefly through the data set and through the variables and kind of start looking at these data so that you also have an idea of kind of how to proceed with your assignment. Okay, so here's the overview of the data set. That is also discussed in the chapter. There are a couple of different variables. We have social demographics, sex of the voter, age or year of birth. We have previous participation, so that's primary 2004, whether a voter turned out in the 2004 primary election. We have the type of messages that were received. Again, control was no message at all, civic, neighbors, and Hawthorne, so this like you are being studied message. And then we have the outcome measure, primary 2006, whether a voter turned out in the 2006 primary election. That's a dichotomous outcome. It's equal to 1 if the voter actually turned out and 0 if the voter abstained. And then we have an additional variable, household size. If we want to load this data into R, we can use this using the read.csv command, since this is a comma-separated spreadsheet file. If we want to kind of explore this data set, we can look at the structure using this str command of this data frame, and we see an overview of the variables, and we see the first outcomes of the first couple of observations for each of those variables, for sex, year of birth, and so on. And you can see that kind of is consistent with the description in this table. Okay, we can also look at the first set of observations using the head command. So that just gives us, again, the kind of first 6 observations of the whole data frame. And of course, it's cut off here a little bit, but you kind of, it always helps once you load the data and kind of get a first look at how this data set is actually structured. You also see that it's quite a large data set. So we have 305,000 observations that were all registered voters in that area in Michigan. So of course, what we want to do is we want to explore the treatment effects, and we want to explore whether the randomization was successful. And I'll talk in a second what we mean by the randomization being successful, right? So first, we want to explore, like, if we want to look at the basic outcome comparison between treatment groups, we can just look at the turnout rate for each individual group and compare them to each other. In this case, we're computing the averages using the tapply command. What the tapply command does is it basically computes a function, in this case the mean, that's the third argument here, for a given variable. That's the first argument, social dollar primary, so that's the turnout rate in 2006, divided by categories of a second variable, and that's the second argument here, social dollar messages. And if you remember, social dollar messages was the 4 different treatment categories, right? So what tapply does is, ultimately it says, take the variable primary 2006, again that's a dichotomous variable with 1 if the person voted, 0 if the person didn't vote, separated according to the messages variable that is in the same data frame, so social dollar messages, and then for each of those subsets compute the mean. All right, and then the outcome, of course, will be a 4-element vector with averages for each individual group. So civic duty, control, Hawthorne, and neighbors. Okay. And we see now this is the average of a dichotomous variable. So that's directly can be interpreted as the percentage or the proportion of voters in each of those categories that turned out in the election. And we see that across all 4 groups, turnout is around 30% in the primary local primary election. We do see some differences between the control group with 29.6% turnout and both the civic duty, Hawthorne, as well as the neighbors message. Okay. So now if we want to estimate the sample average treatment effect for this experiment, we want to basically following the arguments from the previous video, we will look at the difference in the outcome measure between the treatment groups and the control group. Okay, so in order to do that, we can basically run the same command, tapply. Note here how we're basically excluding the second element of that vector. What does that mean? That means we're excluding the control condition. Okay, so we're running the same command, but at the end we're including a selection operation using this bracket notation to exclude the control condition from this vector. And then from that we subtract the average turnout rate for the control condition, right? So that's basically basically this average 0.2966, right? Why are we not using the tapply command in this to subtract this? Well, this is a little bit more efficient. We're just computing one mean for that specific group that we want, rather than computing it for all groups and then just selecting one. Okay. So the result then is, of course, a 3-element vector where we now see the difference between each of the 3 treatment conditions and the control condition, right? And so we see in the civic duty condition, compared to the control, turnout was 1.7 percentage points higher, higher than in the control. For the Hawthorne treatment, so you're being studied, this message, the treatment effect seems to be slightly larger even, so the increase in the turnout rate is 2.5 percentage points compared to the control group. And the largest effect is observed for the social pressure condition. So here we see an 8 percentage point increase in the turnout rate compared to the control group. Of course, we don't, this is kind of the first check of the treatment effects, the difference in the control, between the control group and different treatment groups. But of course, we want to make sure that our treatment assignment actually worked, right? Remember, in order to overcome this fundamental problem of causal inference, and in order to be able to say, okay, the treatment group and the control group are comparable and we can just look at the difference between the two in order to estimate the treatment effect, we need to be sure that the treatment assignment was actually truly random. Okay, so how do we make sure that the treatment assignment was actually truly random? Well, we can look at the randomization itself and examine whether across these different treatment categories and the control group, whether other outcomes that shouldn't be affected by the treatment itself, so turnout in 2006, whether they are balanced across these treatment groups and the control group, right? So this is what we do here. We look at the balance in other covariates, and specifically we're looking at the turnout rate in 2004, right? So this is the turnout rate in the primary election before the treatment was actually administered, right? So there's no way this treatment could affect the 2004 primary election. If our randomization worked properly, then we would expect that these turnout rates, the 2004 turnout rates, should be equal across all treatment groups and the control group. If something went wrong with randomization and we, for some reason, were more likely to contact people with certain characteristics in this experiment, then we would, for example, see imbalances in turnout in 2004. Okay, and what we see here is there are only very minor, very small deviations in the turnout rate in 2004 between the treatment and control groups, so we can be fairly certain that randomization here was successful, at least when we evaluated based on prior turnout rates in 2004. In the assignment for next week, we'll look at yet another experiment that is similar in the sense that it was a field experiment where people were directly contacted, but in a different context. Specifically, we're going to look at a paper that received a lot of attention, both for initially very encouraging and very convincing findings, but then ultimately this paper had to be retracted because it turned out that actually there was scientific misconduct and these data were actually fabricated and made up. And we're going to talk about how this was kind of how people found out about this and kind of diagnosing this scientific misconduct we will do as well. But we'll start here taking this paper at face value, kind of keeping in mind, okay, later it was retracted, and we'll talk more about this in subsequent weeks. Okay. So the title of the paper is "When Contact Changes Minds: An Experiment of Transmission of Support for Gay Equality," and this was published in Science, and again it was retracted, and the data ultimately was completely fabricated. But I should say, and again, we'll come back to this, but I should say later studies kind of confirmed the underlying effect. but with a completely new study because but yeah. Anyhow, ultimately, the question is a really important one. The question is, can we effectively persuade people to change their minds on topics where a lot of people have very strong opinions? So this was in the context of course, marriage equality, and specifically the context was ultimately whether same-sex marriage should be legal, in this case in California. All right, and so there are a lot of theories about whether, when and under what conditions people change their mind. One very important theory is this contact hypothesis, which states that outgroup hostility diminishes when people from different groups interact with with one another, right? So if I am if I have a certain opinion, if I, suppose someone is opposed to marriage equality, but then comes into contact with, a lot of gay couples, he or she might change, they might change their mind because they were in contact with these couples, and then, kind of are more likely to empathize with their situation, and so on, right? So it's a basic theoretical argument, but it's not directly straightforward how we can best test this argument. Okay, and so these two authors, Lacour and Donald Green, ran, or at least they said they ran, ran two randomized controlled trials in Los Angeles. As I said, they were timed around the Supreme Court decision to legalize gay marriage in California. That was in 2013. And specifically, they had a 2x2 factorial design where they had either gay and straight canvassers with similar characteristics that basically went from door to door and delivered either a canvassing message on same-sex marriage and a canvassing message on recycling. Okay, so that's kind of the control comparison group. Okay, these persuasion scripts that they used were similar, except for the fact between the gay canvassers and the straight canvassers, where that the gay canvassers were personally affected by the specific decision because they would like to get married, but the law currently, or at that time, prohibited it, whereas the straight canvassers basically just described affected either children, family members, or friends who would like to get married but are prohibited or were prohibited by law at that time. The outcome measure. The outcome was ultimately measured using an unrelated panel survey. So these people were then contacted again by a supposedly unrelated survey after they were contacted by the canvassers, and there they were asked about their support for same-sex marriage. And the original study received a lot of attention because it showed from psychology, we know that it's very difficult to change people's mind under most circumstances. It's not so easy, especially with something like, same-sex marriage, where people have, fairly strong prior opinions. But this study found very large and lasting effects of persuasion, especially using the same-sex marriage script delivered by gay canvassers. So gay canvassers who were personally affected had the strongest kind of persuasive effect that was also long-lasting. But, and again, we're going to talk about this more in the upcoming weeks, ultimately this study was debunked. Turned out that one of the authors, Lacour, completely made up the data. It wasn't actually collected, and therefore it had to be retracted. And that debate, of course, gained a lot of attention. So what you'll have to do in this assignment is to look at these data, and here's again an overview of the kind of a smaller subset of the original data, where we have two different studies included we have 5 possible treatments. We have different survey waves. So these respondents that were contacted were asked in a multiple wave panel survey in a total of 7 waves about their opinions on gay marriage. And the outcome measure is a 5-point scale on same-sex marriage, marriage equality, where higher values indicate support. Again, here's a quick overview of the data set. We have, again, a large, a pretty large data set of 69,000 observations for 4 variables. 69,000 observations, again, does not mean 69,000 people, because keep in mind we had 7 waves in 2 different studies. So individual observations, individual respondents appear 7 times in each of these in this data set. So I'm not going to go through the assignment itself. I just want to kind of give you a first look at these data. We can, of course, the first thing we want to do is to explore the treatment assignment, and kind of similar to the argument that I made previously, make sure that this treatment assignment was actually truly random. Well, or as a first step, we can look at the treatment assignment, or look at the number of observations in each wave first. We see here, this is now a cross tabulation of study 1 and study 2 for 7 different waves, and we see here how many respondents participated in each study in each wave. Okay, we see study 2, for example, didn't have administered wave 5 and wave 6. And in our first step, we will focus on the baseline survey in study 1, so we can subset our data by focusing only on study 1 and only on wave 1. Why do we only focus on wave 1? Wave 1 was the wave that was basically administered before the canvassing treatment was actually administered. So we can use it in order to examine whether the treatments were randomly allocated, or look at in order to look at the distribution of treatments at least. Okay, and so we see in this context that 55% in study 1, 55% in wave 1 were not contacted. They were in the control group, and then we have about an roughly equal distribution of different canvassing approaches. Here the recycling script by straight canvasser, same-sex marriage script by gay canvasser, and the last one unfortunately is cut off. So in this assignment you will explore this in more detail, look at attitudes prior to the canvassing event and after the canvassing event, and explore these treatment effects in the context of this study. Alright, this is it for this video. In the next video I'm going to talk about observational studies.